Yet another application of combination or C is selecting any number of objects from a given n objects. The different why is this different is the number of objects that you are selecting is not specified. You could select any number of objects. Now there are two branches in this and you need to make a clear distinction between them. The first is n distinct objects. So let's handle this first. In how many ways can I select any number of objects from n distinct objects? Since it's not specified, I could select one object, or I could even select two objects, or I could select three objects, and so on, right till I could select all n objects. And just as a case exists of selecting all the given objects, there is one more case of selecting none of the objects. So 0 also you would have to include in this case when nothing is specified, let's say. Right. Now treat each of them individual. We know the utility of an OR is consider them as different cases and handle each individually. In how many ways can I select 0 out of n objects is NC0. 1 out of n objects is NC1. 2 out of n distinct is NC2, NC3, and all of them is nothing but NCn, which is one way, but let's just maintain the format out here. And since there's an OR, I need to add all of them. So this is the answer to selecting any number of objects out of n distinct objects. And what is interesting is if it starts with a NC0 and we have an 1, 2, 3, 4 right up till n, this expression boils down to as simple as 2 raised to n. We will shortly see this logic of why is it 2 raised to n. But first let's just solve a simple question based upon this. So the worded question based upon this is, let's say this room here has 5 different tube lights or 5 bulbs, let's say. In how many ways, the number of ways in which room is lighted. Now when would I say is the room is going to be lighted? The room could be lit even if one bulb is on, and the room is also lit if 2 bulbs are on. The room is lit if all the 5 are also on in that case. One might also object to the fact that there are 5 bulbs. Are they distinct? While it is not given and physically they might appear the same, but they are definitely distinct because of the different positions that they are placed in the room. So this bulb on the right being lit is different from this bulb on the left being lit as such, right? So we would have to consider them as distinct. So what's the new thing out over here? So is the answer 2 raised to 5 here directly? Not really. What is the difference here is just that I at least need one bulb to be lit. So out of 5, one bulb could be lit in 5C1 ways. Think there are just 5 bulbs. This could be lit as one way. Another one could be lit a second way, and so on. That is 5C1, 5C2, and so on, right up till 5C5. But the difference here is that 0 bulbs being lit is not acceptable. So to correct our answer, we just need to do a 2 raised to 5 minus 1. So this minus 1 is always when at least 1 is selected. So whenever we have at least 1 is selected, we need to do a minus 1. This example is a very common one in exam. Another example could be just of buffets. So let's say there's a buffet spread of 7 different dishes. In how many ways can I let's say pile my plate up or eat out over there, right? So there are 7 of them. I could just take one dish, but that one dish could be taken in 7C1 ways. I could also take 2 dishes, but which 2 dishes are also important because they are distinct dishes out over there. So that also the answer will be 2 raised to 7 minus 1. To understand this logic of 2 raised to n. So questions are pretty straightforward out there. To understand this logic of 2 raised to n, let's say there's one object, the first object, let's say. What choices do I have with the first object? I could either select or not select. So there are two choices with the first object, two ways. With the second object, let's say, do I again have, I could either select or not select? And is this choices independent of the first one? So I could further have two ways, and so on it could continue. With the third object I would again have two ways, and with the nth object I would again have two ways. Each of them is independent. I could have further two ways for every prior selection. So the answer is going to be 2 into 2 into 2. How many times? N times. So that is nothing but 2 raised to n. If this thing is not clear out over here, let me just take an example of, let's say I have a pen, eraser, and let's say a marker. So there are three of them. Let me just mark them as the leading digits P, E and M. So this tree will also help us in further questions. So P I could select or I could not select. Having done that, I could go in further two ways. The eraser I could select or not, and this two ways exist for each of the prior ways. So now I have four different ways. For each of these four ways, I would further have two ways: select the marker, not select the marker. Select the marker, not select the marker. Marker is selected, not selected, and so on. So this is going to be into your 8 different ways. The first way out over here is all three are selected: pen, eraser, marker. The second is just a pen and an eraser, right? And the last, remember, is neither, none of them is selected, right? Whenever you are using this tree, this is the one case you would subtract if at least one has to be selected in this case. I hope this is clear. Let's quickly move on to the next major change in this question. What if all of them are identical objects? Well, the selecting any number of objects still remains. I could select 0 or 1 or 2 or so on, all the possible ways, or I could select all n objects as such. But the distinction now comes with, in how many ways can I select one object out of n identical objects? While physically there are n different objects, but let's look at a library. Let's say that library has 100 books, but the issue is all these books are the same copy of the same book. Let's say my experiments with the truth. Now, would you really say there are 100 different choices for me to borrow from this library? Or let's say you borrow one book called My Experiment with the Truth. You go and say to your friend, I borrowed this book. You borrow another book which is a copy of the similar one out of there, and you say I borrowed this book. Would the friend understand that there is any difference out here? So if they are identical, there is only one way in which I can borrow. Similarly, for two books also there is only one way. But borrowing one is definitely different from borrowing two, because you could go and show, look, I borrowed one. You could go, I've borrowed two, which is a different case. Similarly, borrowing none of the book is one way. Each of them is going to be one way. All of them is also one way. So 1 plus 1 plus 1 plus 1. And mind you, this is going from 0 to n. So the answer in this case is going to be n plus 1 ways. And if I have to borrow, just as I had seen earlier, if I have to borrow at least one object, borrow in the sense, if I have to select at least one object, then eliminate the case of 0, and that the answer is going to be n ways. Right? So the logic to understand this is pretty easy. What you need to realize is, when would I have identical objects? Other than the question specifically mentioning that there are n identical objects, or in an urn there are n identical marbles or so on, and I have to remove off one marble, is just one way. I have to remove two marbles, is just two ways, and that is just one way. Other than those, any fruits of one kind, fruits of a kind, or flowers, all of these of a kind are going to be identical. For example, if let's say a fruit seller has 10 apples out over there, and I need to purchase 2 apples, which 2 apples we would not distinguish. We will say all the apples are identical out over there. So the purchase is just purchasing 2 apples, which 2 does not matter out over there. So let's do a question out over here. A fruit seller, let's say, has 4 apples. So this is the last stock left, 4 apples, 5 mangoes, and let's say 6 chikus. Now, in how number of purchases that I could make, and obviously different purchases, the number of purchases, let me add a condition such that at least one of each type is bought. B-O-U, bought. Now, since one of each type is bought, from the apples I could either buy 1 apple, 2, 3 or 4. Is there different number of ways of buying 3 apples? No. Which apples does not matter. So with apples I have 4 choices. In 4 ways I could buy apples. With mangoes I have 5 different ways, and with chikus I have 6 different ways. And what do I need to do? I need to multiply them, right? Why do I need to multiply? If I just go textbookish ways, am I buying an apples or mangoes, or could I buy apples as well as mangoes? I could buy as well as mangoes, so it's a multiplication. However, I would still ask you to think in the tree structure. With apples, the 4 different ways are, I could buy 1 apple or 2 apple and so on. Having bought an apple, there are further 5 different ways of purchasing a mango. 1 mango, 2 mango, 1 mango. Why is this method or way different from this? Both have 1 mangoes, but in this purchase I have 1 apple, whereas in this purchase I have 2 apples. Having bought them, further there will be changing the question yet again, such that at least 1 fruit is bought. Now it does not specify one of each type. It just says 1 fruit. So is it possible with apples, is it possible that I might buy 0 apples? Pretty much. So with apples I have 5 different ways. And what are those 5 ways? Those 5 ways are 0, 1, 2, 3, 4, 5. With each of them there are no further ways since they are identical. Is it possible that I buy 0 mangoes? Yes. So there are 6 different ways of purchasing mangoes. And is it possible that I buy 6 chikus? Few students says it's not possible because you have not bought any. This 5 ways suggests that there is a possibility that I bought apples. So I am asking you independently, with chikus, only with respect to chikus, is it possible in some way that I buy 0 chikus? Pretty much. I could have bought some other fruit in that case. So with chikus I could still buy 7 different ways of purchasing, right? And there is a multiplication out over here. However, when I multiply all 3 of them, one possibility comes in where I buy 0 apples, 0 mangoes, 0 chikus. So I would have to subtract that 1 possible ways. So 5, 6 are 30, 30 into 7, 210, minus 1, 209 are the number of ways in which we could make this purchase. If this, quite a few people also erroneously say subtract 3. 0 apple, 0 mango, 0 chikus. Not really. We are subtracting only 1 case of 0 apples and 0 mangoes and 0. And this is the beauty why I keep telling you go back to the number tree, or go back to the tree, sorry, and try to realize this. So looking at this tree, listen, there is 0 apples bought, or there could be 1 apple bought, 2 apple bought, and so on. With each of them there are further quite a few ways with respect to mangoes. 1 is 0 mangoes, 1 mango, right up till 5 mangoes. This also has 0 mangoes, 1 mango, and up till 5 mangoes, and so on. Further with this way there could be 0 chikus right up till 6 of them. With this there could be 0 chikus, and then I could further have right up till 6 of them, and so on with each of these branches. So which one are we subtracting? Let's see. The first branch refers to 0 apple, 0 mango, 0 chicos. This is the one that is not acceptable. Is this branch acceptable? Let's ask ourselves. I bought 0 chicos, I bought 0 mangoes, but there is a 1 apple out over here, right? So this will be acceptable. In fact, since there is at least one or so, all of these will be acceptable. Is the 0 chicos acceptable here? Yes, because there's a 1 mango here, there is a 1 out over here. So the only case to subtract is the first case out over here, right? Hope you get the logic. So be a little careful about what is the at least given with. Is it given in the totality or is it given for each kind as such? And lastly, could distinct and identical be merged together? Yes, they could be merged together, though I haven't seen a question like this being asked. And it becomes a very, let's say, made up type of question. But still, let's say, a florist have 5 roses, each of a different color. Each of a different color, if it is mentioned in the question, you would have to, while they all are roses, effort is being taken to tell you that each of them is of a different color, so they are distinct. And he is left with, let's say, 6 what shall we say, white lilies. So all of them are identical white lilies. In how many ways? The number of ways of purchasing, or let's say you want to form a bouquet or so on, purchasing, let me just write, such that at least 1 rose and at least 1 lily is bought. Since there's at least 1 rose, since roses are different, mind you, we would have to go to the 2 to the power 1, right? But there's an at least 1 rose. So in how many ways can I buy those? 2 raised to 5 minus 1. In how many ways can I buy at least 1 lily? And remember, the lilies are identical in this case. So in how many ways can I buy at least 1 of them? The number of lilies, 6. 1 to 6, that is 6 ways in this case, right? And so in how many ways can I make the total purchase? For every purchase of rose, the purchase of lilies could be different. So this is the answer. And if instead of one of each kind, if at least 1 flower is bought, so it does not mention which type you buy, it just mentioned 1 flower has to be bought. So individually with roses, there is a possibility of buying 0 roses, so you don't subtract the 1. With lilies, there is a possibility of buying 0 lilies, so that is going to be 7 different ways, 0 to 6 in that case. And combined together, there would be 2 raised to 5 into 7, but now you would have to subtract 1 case where you would not have bought a rose nor you would have bought a lily. So these are questions related to selecting any number of objects where the number of objects are not specified. Later when we see grouping or when we see distribution, hats or balls being distributed in boxes, again we do not have a number specified. We will be using this funda then. Thank you.